another equation that actually turns out to be quadratic, this. Okay, so how do we solve this? Well, we've got the square root of quantity x minus 4. If we square that, we're just going to get plain old x minus 4. So we square both sides. And we get x minus 4. But I'm going to write it out exclusively. Square root of x minus 4 squared equals quantity 2x plus 5 quantity squared. Okay, so if we square this, we get x minus 4. And now this equals 4x squared plus 20x plus 25. Okay, so now we have this equation. Of course, I've got some dots here because you've got to be able to square this. You write out 2x plus 5 times 2x plus 5 and use the distributive law. And don't write that as 4x squared plus 25 because that would be totally wrong. Distributive law gives you this. Okay. Then we have, okay, without being too meticulous, there's some steps here. We're going to subtract x minus 4 from both sides and then switch the left and right hand sides so it looks like a quadratic equation. So we have 4x squared. Then we have a plus 20x. We subtract x minus 4. It's going to give us 19x. And then we subtract the x minus 4. We're going to have to add the 4 then. And we're going to get plus 29 equals 0. And it looks totally hopeless here. I'm not even going to calculate the discriminant. These numbers are prime for lots of reasons. I see we're going to have to use a quadratic formula on that. Okay, so there we have another instance. Then you do have to be careful get two solutions, but maybe one will make the square root, will make x minus 4 negative. So square root of x minus 4 ain't real. So you got to be careful, so you got to check your solutions, which you should be doing. Anyway, I'm convinced that one of the reasons people have trouble with algebra is they're not in the habit of checking their solutions. Because you learn a lot when your solution doesn't work out and you've got to go back and see what you did wrong. You get immediate feedback on whether you did it right or not. Okay? Well, okay, that's one case. Another case that's fairly straightforward. Let's say you got something that looks like this. Well, you multiply this out using the distributive law. And I'm going to do that in detail now since we're not in a problem with other issues. Okay, so we want to illustrate the distributive law. And you know what people do is they'll draw a little thing here, and they'll draw a thing here, and a thing here, and a thing here. And I did the same thing, but I understood the distributive law. And those, you understand it better if you write it out. Okay, so x minus 2 times x plus 5 is x times x minus 2 minus 2 times x plus 5. And then 3 times the quantity x minus 4, of which we can multiply through 5 to 3. Okay? Now, we have to use the distributive law again on this term and this term. So x times x minus 2 is x squared minus 2x negative 2 times x plus 5 is negative 2x minus 10. That equals 3x minus 21. I'm going to do this in the kind of detail that I really want to see, even with these others. So we're going to say now that x squared minus 2x minus 2x minus 10 and I wrote something down wrong here, so I've got to fix it. Minus 2x and minus 2x, look, it's x times x minus x plus 5, not x times x minus 2. And I apologize, sometimes my eye picks up something and my brain doesn't fire. Okay, so we have x times x plus 5 minus 2 times x plus 5. And that's going to mean that we have a plus 5x here. And then 5x minus 2x is 3x. And then we have the minus 2x and the minus 10. Then it's going to be minus the quantity 3x minus 21 equals 0. Then we distribute the negative. A negative in front means like multiplying by negative 1, so it's an instance of the distributive law. And negative 1 times 3x is negative 3x, negative 1 times negative 21 is plus 21. And now we just put everything together. We have a 3x here and a negative 3x, which gives us 0. And then we have just the negative 2x. Of course, we have the x squared, so it's minus 2x. And minus 10 plus 21 is 11. 11's prime, because I'm going to factor. So now we use the quadratic formula. Now, another simple instance is this. Okay? Now we can multiply this out using distributive law, use a quadratic formula or factor. But if we were to multiply this out, and we could then factor it, and when we factor it, we get this. Okay? So if you can factor the polynomial into two factors, and this is the kind of thing you would end up with if you had a factorable quadratic. The only way this can be 0 is if x plus 4 equals 0, or 3x minus 5 equals 0. Now, x plus 4 equals 0. Is same as saying x equals negative 4. 3x minus 5 equals 0. Without going through the details of rearranging the equation, it's pretty clear that we're going to get x equals 5/3, but of course, there's some steps in here, so I'll put the dots there, the ellipsis. Okay? So there's your solution. Okay? Now, you can check. You plug in negative 4 here, you get 0 times, what, negative 17. 0 times negative 17, 0. Really doesn't matter what this is. If this is 0, you're going to get 0. And then 5/3. 3 times 5/3 is 5. 5 minus 5 is 0, so this is 0. And this is, well, 5 2/3 if you like, but it doesn't matter. 0 times whatever this is going to give you 0. So these are solutions. Now just to illustrate the same thing, if we got the good old x squared plus 5x plus 6 equals 0. Now, this one is easily seen to be factorable, and people tend to be pretty good at factoring. So if you're good at factoring, you want to look. If it looks like it might be hopeful, which this one certainly doesn't, this one even less so, But if you got something like this, you can do it. So you can factor this into x plus 3 times x plus 2 equals 0, which means that x plus 3 equals 0, or x plus 2 equals 0, so that x equals negative 3, or x equals negative 2. And those are your solutions. Now, if you use the quadratic formula, if you didn't notice that it was quadratic, you would end up with x equals negative b, b is 5, plus or minus the square root of b squared minus 4ac. B is 5, b squared is 25. 4, a is 1, c is 6, a times c is 6. 4ac is therefore 24, and it's minus 4ac, so there we have that, over 2 times a, which is 2 times 1. Well, that equals negative 5 plus or minus what? 25 minus 24 is 1, and the square root of 1 is 1. Okay, so you get negative 5 plus or minus 1 over 2. So that would be negative 5 plus 1 is negative 4 over 2. Negative 5 minus 1 is negative 6 over 2. And negative 4 over 2 is negative 2. And negative 6 over 2 is negative 3. So the quadratic formula, if you happen to miss the fact that it's factorable, it's still reliable. It's always reliable. Okay, so a little bit more.